Hello Senior 1 students, this is Mr. Karim Rashad, and in this video I'm gonna talk about properties of acids and bases. Number 1, properties of acids and bases. Uses of acids. Acids used in many industries like fertilizers, medicines, plastic, car batteries, and explosive. Also, uses of bases. Bases used in many chemical industries like soap, detergents, medicine, dyes. Acids and bases in our daily life. We have ascorbic acid and citric acid. They are found in lemon, orange, tomato. Lactic acid found in yogurt, milk, cheese. Carbonic acid and phosphoric acid found in soft drinks. And sodium hydroxide found in soap. Hydrated sodium carbonate found in washing soda, and sodium bicarbonate found in baking soda. Physical properties. Acids, they have sour taste and they change the color of blue litmus paper into red, while bases have bitter taste and they change the color of red litmus paper into blue. Chemical properties. Number 1, acids can react with active metal producing salt of acid and hydrogen gas evolves. Like magnesium can react with hydrochloric acid HCl, and the magnesium will take the chlorine from H, leaving hydrogen gas to evolve. Number 2, acids can react with carbonate or bicarbonate, producing water and salt of acid and carbon dioxide. So we can say acid plus carbonate gives salt plus water plus carbon dioxide. For example, calcium carbonate CaCO3 plus hydrochloric acid HCl, they produce calcium chloride CaCl2 and water H2O plus carbon dioxide CO2. Example number 2, sodium bicarbonate NaHCO3 plus hydrochloric acid HCl, they produce sodium chloride NaCl plus carbon dioxide CO2 plus water H2O. Number 3, acids can react with bases producing salt and water. For example, sodium hydroxide NaOH plus hydrochloric acid HCl, they produce sodium chloride NaCl plus water. Example number 2, sodium hydroxide NaOH plus nitric acid HNO3, they produce sodium nitrate NaNO3 plus water H2O. Acids and bases theories. We have 3 theories to define acid and base. Number 1, Arrhenius theory. Each theory will give a definition for acid and for base. Arrhenius acid, it's a substance ionizes or dissociates in water, gives hydrogen ions. And Arrhenius base, it's a substance ionizes or dissociate in water, gives hydroxide ions. That means any substance produces H positive, it's an Arrhenius acid, and any substance produces OH negative, it's an Arrhenius base. Some defects of Arrhenius theory. Number 1, carbon dioxide gas, it doesn't contain H positive and it dissolves in water given acid. Number 2, ammonia NH3, it doesn't contain OH negative and it dissolves in water given base. Number 2, Bronsted-Lowry Theory. This theory, it doesn't require acid and bases to be in aqueous solutions. Bronsted-Lowry acid, it's a substance that gives H positive, and we can call H positive as a proton. So Bronsted-Lowry acid, it's a proton donor, and Bronsted-Lowry base, it's a substance that can accept H positive, or we can say it's a proton acceptor. And here we can see that when a Bronsted-Lowry acid gives a proton H positive to a Bronsted-Lowry base, the Bronsted-Lowry acid changes to be conjugate base. And when the Bronsted-Lowry base takes a proton, it changes to be conjugate acid. We can define conjugate acid. It's a substance produced when the base accepts a proton. And the conjugate base, it's a substance produced when the acid loses a proton. So we can say that when the acid leaves the proton, it changes to be conjugate base. And when the base takes the proton, it changes to be conjugate acid. Number 3, L.L.S. theory. L.L.S. base, it's a substance have many electrons, and it can give an electron pair or more, while the L.L.S. acid, it's a substance that accepts an electron pair or more. So we can say L.L.S. acid, it's an electron pair acceptor, and the L.L.S. base, it's an electron pair donor. Here we can see that the fluoride ion has many electrons, has 8 electrons around it, and H positive has no electrons. So when the fluoride ion gives electron pair to H positive considered as L.L.S. acid, and F negative considered as L.L.S. base. The second example, we have ammonia molecule NH3 has electron pair, and it will give this electron pair to the H of water molecule to give NH4 positive and hydroxyl ion OH negative. Thank you, Senior 1 students.